Good afternoon. Welcome so much to our session today on best practices for a high-performing Wi-Fi network. I'm Chris Riley. I want to say thank you so much for joining us today. I'm joined by Alex Wilson, who's wireless consultant, and Brian Sateski, who's with HPE Aruba. And he'll be looking at some specific technologies that HPE Aruba has on the wireless front. So we've got lots of information here for you today. We all are so dependent upon wireless and our Wi-Fi networks. We want to make sure that they're performing well for our users, and we'll be jumping right into that. So just a little bit of housekeeping, taking a look at agendas, that sort of thing. So first of all, I will do a few introductory remarks, and then Alex will really kind of do the background on some of what are some of those best practices for making your Wi-Fi network as good as it can be. Then after that, Brian will look at some specific HPE technology, HPE Aruba technology that can help deliver on those promises for you to really make that network sing. All right, a little bit of housekeeping. So the first, hopefully you are enjoying some pizza. If you're not, you'll see Julie Dellinger's email address on the screen. Julie can help you with any pizza conundrums. Give them just a few extra minutes. If you're working from home, they may be trying to find your address. If you're working from your office, sometimes those office doors are locked on the outside, and you may find a delivery person on the other side of that, or wherever food disappears to in your office, check there. But if not, just reach out to Julie. She'll be happy to help you. All right, additional housekeeping during the presentation today, audio is in presentation mode, so you'll be able to hear the three of us, but sadly we can't hear you. But we do that on purpose, not because we don't want to hear you, but we want to make sure that any noise or background or music on hold, any of those types of things where participants may be, doesn't come through to the whole group. But you can reach me at any point through the chat tab throughout the session today. I'll be monitoring that. Questions, as they come to mind, just drop them right into the questions tab. We'll save those up to the end. I'll read those out to Brian and to Alex after the presentation piece is over, and then they can respond to your questions there. The other advantage of having in writing is if it's something that's very particular for you, or if there's just not enough time for all the questions at the end, we can be sure to get back to you with answers. We want to make sure this is an educational experience for you today, and that you get your questions answered. This presentation and then the recording of this webinar will be sent to you by email later on today. And then finally, there's a quick evaluation you'll get after the session. If you can just take a second to do that, literally it doesn't take any more than a minute. And that'll give you a chance to let us know how we did so we can continue to improve and keep these educational and beneficial to you. It also gives you an opportunity to say, what else do you need? And we'll talk about some of those things that we may have. There's some options that you'll see on the screen. That way we can make sure that you're getting good resources to help you build a good wireless network. All right, for those who are newer to System Source, just to spend a minute on this. So System Source, we've been around since 1981. There's about 70 of us at System Source. And a lot of folks come to us when they first need to acquire new technology. And that could be on the end-user computing side, laptops, desktops, printers. But the bulk of what we do at System Source is in the modern data center. And the modern data center can consist of traditional on-prem, as well as the cloud variants, which could be Amazon Web Services, heavy work in Microsoft Azure, or any place else that computing storage resources may live. It could be at software as a service, colo centers, could be at our data center, other data centers that you may have. Regardless of where the resources live, I think servers, compute, storage, network infrastructure, switching, which we'll talk a little bit about, wireless access, all those types of things, virtualization, security, firewalls, all those types of pieces. We kind of do that design, implementation, troubleshooting, and security work around all of those types of pieces that make up the modern data center. Heavy work with HPE as well as HPE Aruba in doing a lot of that data center work. But people are acquiring because they want to improve. So we've talked a little bit about consulting and cloud services, a couple other areas. One is training, with over 600 or 700 courses available at any one point on our training schedule, all available remotely on about 36 different either manufacturer-specific trainings, think like a particular training course that you might be taking, like in a Microsoft certification track or just knowledge, or through end user or through general types of things. So one could be in a Microsoft security type of topic. No, it could be on a general security type of topic. So there's courses across that waterfront. Present is professional AV, digital signage, all the WebEx, Zoom, Teams rooms, so all the displays, projectors, microphone systems, speakers, all of those types of things are done by our professional AV group. And finally, we maintain all these things either on a reactive basis. You call us when things go bump, whether during the day or bump in the middle of the night. We can provide that kind of service and support for you. And you can do all of that through our main number, whether you have a contract or not. You can call that main number both during the day and after hours. Or managed services, where it's a proactive approach, where we are the IT department for dozens of clients in this region. That's a little bit about System Source today. We do have some upcoming webinars. So one is coming up on the 18th, and that's going to be looking at IT remote monitoring and management tool. And we say it's the one that we like. So we've been through a lot of them over the years. We've had one we like, it's called Ninja. So a little spoiler alert there. But we think that that will be some interesting content for those that are managing IT departments. And then the next one will be kind of a quickie by our AV group, audiovisual presentation systems, looking at kind of those top 5 camera resources that we have for video calls. Most of those utilizing AI. And with that, let me go ahead and hand things over to Alex, please.
Well, good afternoon, everyone. Today I want to talk to you a little bit about key factors that will ensure a successful wireless network. This is from design and operation. This is fairly high level. I want to talk a little bit about, quick background. I've been around the tech world since the internet concept was first invented quite a while ago. I do networking and wireless consultations. My experience is pretty much with things like in-building and outdoor Wi-Fi, point-to-point, point-to-multipoint outdoor links, long-haul microwaves. I've built out a number of wireless internet services around the country over the years. I've done a lot of campus networks. I've also done some tower building, climbing, and a lot of fiber leasing. So pretty well-rounded in the wireless world. And I'm going to talk mostly about Wi-Fi today. Some of the key factors that we're going to explore. We're going to take a look at, what makes a good design, what is the right access point vendor for your situation, how to pick them. Some little things about network readiness. Are you ready for your upgrades? Or are you ready to make the plunge? Talk a little bit about configuration, make or break type of things for building out your network. And then we'll talk a little bit about ongoing maintenance as well. So let's get into design done right. And so really, it all starts with a good design. And if you don't have a good design and a good foundation, obviously the rest of the house kind of crumbles and has problems. So a good design starts with a good site survey. I recommend using a design professional that actually understands wireless. This is not somebody walking around with a telephone, or I'm sorry, with a telephone, with a cell phone in their hand going, kind of like, can you hear me now testing? Just looking to see what the signal strength is at any given location, because there's way more to good wireless than just a good signal. And so we want to take a look at things during our site survey. We're going to look at a site walk that's conducted using a proper survey tool. Those could be things like Ekahau, Hamina, CIOs. There are a lot of other lower end products. Combined with a proper testing tool like a Sidekick or the Osseum or other types like this. What these tools do is they gather the data from your existing wireless network or from test access points and allow you to really hone in on how the performance of the network is actually, what it's actually doing behind the scenes and the things that you don't see. I've got a sticky key, so I do apologize. I think my slide just advanced on its own. Anyhow, they're going to do a proper heat map of the existing coverage. They're going to test new placements of AP. So maybe you've got some coverage issues. They can bring in a test AP. They can test that area to see what the coverage looks like. And then they can take all of that data and build a proper model of what a new design should look like. In addition, they can also do network checks while they're going through this, things like your UPSs, your switches, your HVAC, your cabling, to make sure you're prepared for what is coming. So a good design plan is going to account for things such as coverage, where and what level is acceptable or not acceptable. And so coverage is just where does the signal reach? But there's way more to it than that. We also want to look at capacity. And capacity is about how many users, but then also what type of devices and what are the use cases. So obviously somebody just using their phone for texting versus somebody trying to stream live video or uploading large numbers of pictures or Instagram type stuff can definitely have a different effect on it. And what you have to consider too is your capacity or your coverage requirements might vary throughout the facility. So as a really simple example, we recently did one that was a combination of a sports arena, an office complex, and a conference center. And so their requirements for internet service varied in each one. In the office area, it's just your routine use, uploads, downloads, good solid phone calls, things like that. In the sports arena, it's fantastic downloads, but more importantly, that upload capacity of everybody in there trying to upload their short videos or their short clips to their friends and their social media feeds. And then of course in the conference center, you just got massive numbers of people sitting there bored out of their mind from the conference and they want to do something on the internet. And so you're going to take all these things into consideration. We also want to look at the devices that are in use. This includes knowing what are the needs of your client devices. So are these laptops, phones, tablets, hand scanners, various IoT sensors, smart switches, speakers, room controls. I mean, the list goes on and on. A lot of this information you can get from the vendors to help you understand what their requirements are. But as an example, a hand scanner is a very low level device. It doesn't require a whole lot of data transfer. Neither do IoT sensors. But if somebody's on a phone versus a laptop's going to have a better Wi-Fi signal than a phone is going to have. And so those are things you have to take into consideration. What is your predominant audience? A good design plan also takes into consideration the interference sources that are out there. That could include things like point-to-point and point-to-multi-point networks that are in your vicinity, microwaves, and I'm not referring to microwave ovens necessarily, but yes, microwave ovens can cause a problem. Also microwave communication systems on the same frequency ranges that you're using. Various sound systems can affect different frequency bands. So in the past, it used to be 2.4 gigahertz. Today, we have a lot of issues also with the 5 gigahertz sound systems that are out there. And then also your neighbors, businesses nearby, transient things that come and go. As a great example, if you happen to be near a major interstate, like within a couple hundred feet, you're going to see a constant parade of car Wi-Fi going back and forth that'll show up on your scans and such. And so those are things that could cause interference. And then also we want to look at the future needs and expansion. So where are you going to go tomorrow? What do you want to do with this network? Not just today, but 2, 3, 4 years down the road, so that we can build for that future so that you're not backed into a corner. During the survey, they're going to look at placement. We want to use building obstructions to assist with coverage containment. So in other words, we want to try to keep down things such as using the walls, using certain elements of the design, like a steel girder or steel beams that are coming down from the ceiling, things like that, that we can use to help block and contain the coverage so that we're creating coverage cells that are very precise. We need to ensure that the access points are close enough to not require full power for coverage. This is something that a lot of the vendor supplied design tools fail to take into account. They work off the basis that the AP is fully powered, which creates a great coverage pattern, and then you don't need as many APs, but then the problem happens down the road, something changes. For example, you add a wall somewhere, or you split a big office into 2 offices. And now all of a sudden, you need to increase the power to reach that other space, but you're running at max power, you have nowhere to go. So the recommendation generally is design for the upper mid-range of what the AP can do. And then that gives you a little bit of wiggle room to move up, but then also more importantly, be able to bring it down a bit if you're over covering. The key really is to put the access points where the people need the service. In other words, don't make them reach for the coverage. Put it where they need to be. So if everybody's in the office working and you put the AP out in the hallway just because it was easier to wire, they have to go through the wall to get to that AP. And that wall is creating some sort of loss of signal. Could also create certain levels of interference depending on what's inside the wall. And so there's a whole host of issues. And this is why I say put the AP where it's needed. If you don't care about coverage in the hall, or it's not as important, put the AP in the office. They'll get coverage out in the hallway as they're transitioning, but when they're working, you want them to have the best service. And also be very careful with omni antennas, which basically cover a 360 or close to 360 degree pattern in a large open space, as they will tend to interfere with each other. And what I'm referring to here might be like an open office concept, like a cubicle farm. We've done a couple that were pushing 200,000 square foot of floor space with nothing but cubicles. And too many APs in a situation like that, and they're going to interfere with each other. Same thing in a warehouse or a gymnasium or anything like that. You got great coverage up top where the birds are all hanging out, but down below where the people are trying to work, you're lacking the coverage. And so in a case like that, we tend to lean more towards directional antennas. A couple of cautions: be careful with vendor statements regarding how many connections a particular AP can handle. I'm not saying vendors bend the truth, and they really don't. It's just that in order to come up with a number, they have to have a common denominator. And basically what they use is just a connection. So when they say an AP supports 1,000 connections, it's just that. They're connected, they're not doing anything. Because the reality is they can't predict what your users are going to do. And so 1,000 people connected versus 100 people actually downloading are going to be 2 very different things. That 100 people downloading could kill your network or that AP, but the 1,000 connected to it may not do anything. So it's important to make sure you know what real usage is going to be like and what the real usage capacity is on these APs. As an example, one vendor I've worked with in the past, they have an AP that says 1,500 connections, but in reality, when testing it in arenas and other areas like that, we're seeing around 150 to 200 actual users are really the limit on those APs. And that's important to know because 100 to 200 is much different than 1,500. Also be careful about vendor statements regarding the range of an AP. These are typically done in a lab, and so it's based on open space without obstruction. The reality is you're going to have walls, furniture, TV, appliances, various other things, plants and artwork, curtains that are up, maybe not up all the time, maybe they're open, they're closed, cubicle walls, even people. People create a lot of obstruction to Wi-Fi. And so all of these things can reduce your coverage, And so it's very important to note that when they say it covers, say, 1,000 square feet, that is 1,000 square feet of open space without obstruction. So in other words, a perfect environment, which nobody has a perfect environment. The other big caution is the one-to-one replacement. Be very careful with this. If you have an existing Wi-Fi 5 network today, based on older technology that was put out in 2013 or 2016, trying to replace that with APs that were just developed on technology from 2023, 2024, you're going to have a big difference in the coverage patterns. Whether the antennas are arranged differently, whether you're trying to do 6 gigahertz work, these things are going to make a one-to-one replacement fail. And so it's important to design to the current APs you're going to be using, not inheriting the bad design you had before. So remember, if the design's not working today and you do a one-to-one replacement, don't expect the new APs to overcome the design flaws that you had before. So it's important to make sure you design for what you're using. So let's take a look at the right access points and picking the right vendor. So there's lots of vendors out there on the market today, and I'm not going to go through all the, we know who they all are, and they all have great products. And honestly, we're a very, we don't care what vendor we work with, as long as it's the right vendor and they have the right options for what you're looking for. And so some of the things I look at for a vendor is, what are my options? What are the selections? So I'm going to look for, indoor options for all level of use. So I want lightweight APs, mid-range APs, like for in a small conference room. I'd also want APs that can handle larger crowds, such as in an arena or in a large conference room or in a gathering area where we might have several hundred people gathered. I also want to look for a vendor that also has good outdoor options, both for general purpose and large crowds. Sometimes we look at the aesthetics of the AP. What are these things going to look like on our ceilings or walls? Are they things that we want to see up there, or do we want to never see something looking like that? And then also I look for flexible mounting options, such as the ability to pop them on a tile grid, directly on a hard ceiling, connect them to junction boxes, poles, whatever the cases might be. And then also with my vendors, because I'm also doing a lot of work in warehouses, churches, schools, high ceiling areas, I might be looking for a vendor who also has good external antenna options that we can do directional focused coverage in these open spaces. Another very important part of selecting a vendor is getting good support. So does your vendor have offered support with a live technician, or is it easy enough to get to that point? Now, a lot of vendors today, some of the smaller vendors, are using a lot of chat bots and AI to get your answers. One of the questions I often have is, are the answers actually accurate? And I've dealt with this in a couple of vendors where the answers were completely opposite of what the live technicians will tell you. And so it's important to make sure that your vendor, if they're offering a chat or an AI type support, that it's good and strong. And do you have a way to opt out of it and get to a live technician easily? Do they have a good community-based support? Maybe your needs are simple, but you want to be able to discuss with peers. So do they have a good community support system out there? And then also, is it a popular product with plenty of knowledgeable people out there to draw from? Not some brand new startup that's really super cheap that, yeah, sounds great, but nobody knows what it is. So, how are you going to get support? How are you going to get answers to your burning questions to make sure that what the vendor is saying matches reality? So let's move on to network readiness, making sure your network is ready for the good Wi-Fi. A couple of things about newer access points, the new generation of things like Wi-Fi 7 access points. These need more than ever before. And when I say more power, better cabling to handle the higher throughput, newer switches with faster ports, higher PoE levels, and all of this is going to increase your HVAC and your UPS needs to handle the heat need or the heat issues that you're going to get from these bigger UPSs, bigger switches, and so on and so forth. These are all things that you absolutely need to check before you go buy into a new platform, and it's stuff you need to budget for. If you have a lot of older switches that were just 8023AF or PoE capable, and you're buying into Wi-Fi 7 APs, you're most likely going to need to move to PoE Plus or even PoE Plus Plus in many cases. So these are things you must factor into your decisions. Along with that, the cabling, most APs today have options for 2.5, 5, or 10 gig connections. And if you're going to achieve the capabilities of those APs, you're going to need better than 1 gig connections, which is also liable to mean some fiber upgrades here and there. So these are all things you must factor in as you move forward. A little bit about power needs. I'm not going to dive into this in a lot of detail, but it is kind of important because, like I said, a lot of changes now. So the older standard was 8023AF, which was called PoE, but most of these now require AT or BT style power, with some requiring more than 15 watts of power. And when you're calculating your PoE budgets, you need to look at the manufacturer specs on the AP and look to see what is the maximum that it needs. And that's what you need to use in your calculations. If you're looking at what is the average run, I'll tell you right now from a couple of them that I've been working with recently that their max was 12 watt and their average was 4 on a day-to-day basis. But every time you provisioned, did an upgrade, or fired them all up, they shot up to the full 12 watts and then back down. Well, that could cause a lot of your APs to drop offline until they all come up in some sort of order. And you don't have control over that during a power outage necessarily, nor do you have as much control over that during a provisioning when you're pushing out upgrades. So it's important to make sure you're budgeting appropriately. Also remember, when you increase the wattage, you're going to generate more heat. And so more heat, you're going to need more AC. So these are things to keep in mind. Talked a little bit about better cabling. Keep in mind that Cat5 is kind of the standard that's out there, although a lot of people have moved to Cat6 over the last few years. Cat5 is limited to 1 gig at 100 meters or 328 feet. It might support 2.5 gig at those distances, but it's not guaranteed. Keeping that in mind, if you're going to run at 2.5 gig or better, you're going to need Cat6 or Cat6A. Most of these newer APs, like I said, they're 2.5, 5, or 10 gig options. Some of them also have dual ports for dual 5 gigs to give you 10. So in a case like that, you might have to run 2 drops and then do lag at your switch if that's an option that you have. Be mindful of your distance limits on your cabling. Do not forget to consider temperature derating. This is not something that's pushed very much in the industry, but all of the limit standards are based on a 68-degree-Fahrenheit ambient temperature. So when you have a bundle of cable running through the warehouse at 40 feet above the floor, what is the temperature on the outside of the bundle and what's the temperature on the inside of the bundle? Those wires on the inside are going to tend to be warmer, and as the temperature rises above 68 degrees Fahrenheit on the cabling, it will decrease the maximum run length. Now, is it dramatic? Not necessarily. It's not going to necessarily drop you to a point that might be a problem in a traditional small office or even in a school, but in a warehouse where you're making cabling runs that are pushing the 300-foot limit, this could become a problem. Make sure you're also using good cabling contractors that know what they're doing. Make sure you're seeing examples of their work before you hire them. Make sure it's clean work and that that they're not stapling wires to the wall. They're pulling wires properly. They're not yanking them across things. You want to make sure that they're doing the job right and even getting the cable certified when done so that you know for a fact that this is good cabling and you can eliminate that from your mix. Because once you've cabled it, you really don't want to have to go back and recable in most cases. Open warehouse, not that big of a deal. Drop ceilings, not the worst in the world. But if it's a hard ceiling or hard walls, it's not fun to rewire, and it's expensive. Make sure you're also using the right type of cable. This includes using riser and plenum indoors, shielded when running near electrical or motors or light fixtures. For outdoor needs, make sure it's shielded, UV rated casings, properly terminated and grounded, preferably in a conduit. Make sure all your cable runs are properly supported so that nothing is sagging and stretching. And remember, when you go over 100 meters, you're moving the fiber at that point. And if you're going building to building, don't use copper, use fiber. You don't want to put copper between two buildings and give it a path for lightning or for grounding issues. I'm not going to dive into this chart. It'll be here in the slides when you need it, but this is just a compilation of the limits on cabling lengths based on 68 degrees. Some other things to consider, newer switches. We talked about increasing your PoE needs. You're going to need higher capacities. Time to probably upgrade your switches. Always budget the PoE needs, like I said, to the highest usage each device might draw. Make sure you have enough PoE budget to handle your expansion. And then aim your size of your switches to not exceed more than about 75 to 80% of the capacity. So that way, again, you have some wiggle room in case you have to add something to it down the road. Remember, with all of this, you're going to increase your heat in the closets and in the cabinets. So make sure you're increasing your HVAC. Also make sure your UPSs are upgraded along with this in case you're pulling more power. Your runtime is going to drop on some of these. And so it's important to make sure that you're meeting those needs. Taking a look at configuration to try to get some things here, channels and power. Most of your wireless controllers have auto channel and auto power options. Some work better than others. Some don't work at all. Depends on the vendor. You might need to manually tune regardless. So make sure you know how to do it or have somebody on tap that can help you with that. Also, the power that you're transmitting is going to affect the coverage size of the cell. So manage it to a minimal overlap to encourage good roaming. And then one of the goals is really to reduce airtime by the clients. And this requires that the APs be placed and managed to avoid reduced signal and slow throughput. Also, don't necessarily consider putting on throughput limits on your clients, because when you do that, you're increasing their airtime needed to get things accomplished. And when you increase airtime, you take it away from everybody. And so sometimes it's just better to let things fly so that they get through and move on to the next client. Make sure when you're tuning to your device needs. Most of your clients are going to roam between neg 70 and 75. Design your coverage to that threshold. Apple does have some of the strictest rules for client roaming. I'm not going to go through all the details here. There's documents out there from Apple that talk about it in great detail, but these are the basics. What is the roaming threshold? What are the different things it looks at to decide? And when you're doing this, remember, a lot of vendors come up with some really cool options like band steering, minimum RSSI, roaming assistance. Try to resist the temptation to use these because they're not always supported and they don't always work in every situation. What does work is good power management and good channel management. And then now that you have a network, keep in mind, wireless is not set it and forget it. You need to monitor your network to ensure it's working the way it was meant to. This includes monitoring your channel usage, the power, and the client experience. Remember, as your environment changes around you, things like new neighbors with competing systems or new client devices, sometimes worse than the old ones, or higher demand or on your throughput for new use cases, these could all change how your wireless works and you might need to accommodate. So periodic wireless performance surveys and updates and testing and tweaking might be needed as you go forward. Monitoring your network performance factors, things like DNS and DHCP response times, airtime usage, packet retries, doing throughput testing on both the LAN and the WAN side, and making sure that client reported speed tests are just an indication that might need improvement. Don't fully rely on them because they're not testing precisely on the network, and you don't always know what tool they're using. They could be going to a server that's 5,000 miles away. It might be right down the street. You never know. So you want to make sure that you're doing good quality testing. Some basic tools you can use: Ping, TraceCert, iPerf, Wireshark, an internal speed test server. Raspberry Pis make great low-cost computers to run these on. Great tool, Wi-Fi Explorer. You can get it for free on most mobile devices or laptops. You can read the wireless signals. NetSpot is a low-end survey tool that you can use for spot checking. There's a lot of different client experience tools from companies like Seven Signals, Thousand Eyes, NetBees, and then there's also sometimes tools from your access point vendor. And with that, I'm going to turn it over to Brian, and Brian will talk about HPE and Aruba and some options that they have available.
Excellent. No, appreciate it, Alex. Thanks for the introduction and to the System Source team, yourself, Chris, for including HPE Aruba in the conversation today. I'll add an extra note. I did see Chris put a note in the chat. If any questions do come to mind, either anything that Alex already mentioned or on anything that I'm going to cover here in the next few minutes, please put them in that kind of questions box, and we'll address it with the time that we have left at the end of the presentation today. So jumping into things, I've been with Aruba for a little over 11 years. I was with Aruba when we were acquired by HPE. Referencing the slide here, you can see that Aruba was founded back in 2002. We were purchased by HPE back in 2015, kind of finalized in 2016 in the sense of the actual integration piece. One of the big highlights I'll put on here is that home of 100,000 plus mobility engineers, or something that we refer to as the Airheads community. So referencing kind of Alex's comment earlier of, hey, there's some startup vendors out there, they have their community forums. Airheads is a gigantic forum with an incredible amount of knowledge on there that is manned by individuals ranging from customers to partners to our own product managers and even distinguished engineers responding to some of those questions. So absolutely something worth checking out for you to join if you're not already a part of it. And you're good to jump ahead there, Alex. This next slide, won't spend a lot of time on it, just referencing the various solution offerings that we have. I know today's session or content is focused on wireless, but outside of wireless, obviously that's something that we honestly are a networking leader in. We do have other solution offerings to include cloud-based network management, which I will demo briefly today. We do offer wired solution offerings from a switching standpoint, from campus access switching to campus core, to aggregation switching, to chassis, to even DCN solution offerings. We also have gateways that we offer, small gateways for branch sites to large end-to-end gateways. We have SD-WAN solution offerings, as well as VPN functionality built into the gateways, as well as VPN replacement tools using SSE or SASE. So referencing that as another solution option. We do have our NAC offering, NAC being network access control, which is our ClearPass platform. It's actually vendor agnostic, can be used in any vendor environment, regardless of the vendor in place from a wired or wireless infrastructure standpoint. And then lastly, we have our experience management platform, something that used to be called Cape Networks. Now we have rebranded it UXI, or User Experience Insight, which relies on sensors, or actually even agents that you can install on client devices to see the essentially performance of the network from a endpoint perspective. But you're good to jump ahead, Alex. On this slide, and just a fair warning to everybody on the call, only this one and one more remaining from the Aruba standpoint, so not going over too many more slide content pieces here, but this one I would say is going to be the bread and butter, if you will, of kind of the content that I would want to share, referencing our portfolio, our offerings, if you will, from a wireless standpoint. A number of things to kind of explain here if you're not already familiar with any of our AP models. If the AP model series starts with a 5, that means it's a Wi-Fi 6 AP. If it starts with a 6, it's Wi-Fi 6E. If it starts with a 7, it's Wi-Fi 7. We do have a couple newer APs that honestly came out this week, which is the 740 series as well as the 760 series. They were actually announced a little bit ago, but they just got loaded into our quoting tool, honestly, just a couple days ago. In terms of relating back to a couple of statements that Alex made that are incredibly relevant, talking about coverage and talking about capacity, and those are two different styles of design concept, typically speaking, and I'm making some generalizations here. A capacity-based design is often more office focused or convention center focused, to even that kind of sports arena, right? There's a ton of capacity when you're supporting 10,000 seats, versus a coverage-based design, which used to be a lot more common than it is today. Many traditional designs now that are indoor spaces are more capacity. The exception to that rule is warehouse design, right? So in many warehouses, it's either limited applications, limited client devices, or very low bandwidth usage client devices, such as barcode scanners. So many warehouse deployments today are primarily a coverage focused design, not saying that we don't take capacity into consideration, but just noting the two different design types that are out there. And in many cases, there's like a hybrid combination of the two. A big factor that comes into play when choosing an appropriate AP model is going to be client density. So referencing Alex's comment there, I kind of chuckled while on mute of AP that can support 1,000 endpoints, right? And we have that. However, that's not recommended by any means, and not a best practice. Our higher end APs, depending on the documentation you have access to, you might see that it can support up to 512 connections per radio, right? So dual radio, 1,024 connections. Now that is a connected device, not an active client device. So internally, we actually have a kind of AP matrix reference chart. That's still just a best practice. It's not the end all be all, if you will, where that same AP, the active recommendation in terms of active clients connected is 75 to 100 endpoints per non 2.4 gigahertz radio. In most cases, we are avoiding 2.4 gigahertz planning and primarily focused on 5 and 6 gigahertz, but that's an incredibly important call out that Alex made earlier in kind of his presentation and some of the RF design concepts, understanding what the AP is capable of supporting, but also understanding some of the numbers that are out there. The other part of it is it's very hard to justify a fixed number for an AP in the sense of how many clients are supported. So as an example, I'll often say like a 630 can support 75 to 100 endpoints on a single AP. But even with that statement, yes, I'm using a little bit of a range there. I'm a little hesitant in committing to that or putting in writing because it depends on what the endpoints are doing. So having 75 people connected or 75 devices connected, and you have a mixture of internet traffic, I'm checking my Outlook, there's a few people using Microsoft Teams, etc. No problem. If you have 75 individuals all trying to stream 4K content at the same point in time, you might run into more challenges, right? So application usage is absolutely a factor. And I really do think that a lot of the content that Alex shared with everybody on the call here is incredibly relevant from a practical standpoint. Looking at this slide a little further, just referencing the fact that you're seeing series. So series implies that there's more than one model within that series. In most cases, especially for indoor, typically speaking, you're looking at an AP model that ends in a 5, so a 635, a 735, a 725. The 5 at the end basically means it has built-in internal omnidirectional antennas. However, we do have a 634, so if it ends in a 4, it means it has external antenna connectors, then you could plug in an external antenna. Now that's more niche use cases for the traditional indoor office setting, but when you get to the outdoor and warehouse kind of side of the fence, or the right hand side of this slide here, there are going to be more applications where directional coverage comes into play, and even directional from a point-to-point connectivity standpoint, as we do support mesh designs. Lots of different options available to consider here. If there are any questions on any of the models, specifically any of the capabilities of the models, feel free to ask away. And the last note I'll kind of hit home on that Alex did reference to is PUE, right? Power consumption, power draw. The 750 series that you see on here, as well as the 650 series that you see on here, they require more than 30 watts for full functionality, full operation. So, that goes into your planning stages of your switching capacity from a PUE budget standpoint, but also, the throughput potential that those switches can provide from a multi-gig over wired. Now, if we look at other series a little bit further down in the food chain, the 720 series and the 630 series can fully operate on your kind of standard PUE plus or less than 30 watts from a PUE draw standpoint. So definitely a big planning factor, but did want to kind of call out both the 750 and 650 series as AP models that do require more than 30 watts for full operation. So yeah, Alex, I'd say you can go ahead and jump to the next slide. This is the last slide that I'm going to cover here before giving you guys a little bit of a look at our network management platform, Aruba Central. On this slide, we're highlighting some differentiators, right? So things that make HPE Aruba one of the best vendors out there when it comes to wireless feature functionality control. If you're looking at the top left of the slide, you're going to see the reference to client match. Client matches are silver bullet against any other vendor that's out there. It's a patented proprietary technology, specifically designed to reduce the issue of sticky clients. And if you notice the graphic, I know it's a little small to see, but that tends to be a common problem or issue most commonly found with Apple devices. So it's designed to make that roaming experience better for all types of client devices, but it's been around for honestly a decade plus in practical use for several years, and it has been overhauled a number of times, but definitely something that we tout as a differentiator of ours. Error match is a function that is built into our central network management platform that actually optimizes your wireless network over a 24-hour period. It's baked into the platform. It is something that you can specify what time those optimizations occur, but just noting what that is. UTB, or ultra tri-band filtering, is essentially filtering between channels. This is something that not every vendor offers that's out there, especially not the cheaper ones, but it allows for less interference, less noise to play a role or play a factor when looking at channels that are close in terms of their frequency range, right? Looking at the upper end of 5 gigahertz, the lower end of 6 gigahertz. This is something that we can use as a differentiator when talking about tri-radio, tri-band APs. And then the top right note there of traffic control and app RF, I'll actually show that in the demo of the platform itself. This is our feature function that essentially ties in the fact that our APs have a built-in deep packet inspection engine, and we're able to visualize the applications running across the network. And there are certain actions we can take on those applications, or depending on how you set up an SSID, access control that we can take over those applications. So I think we're good with the slide content. Alex, if you want to give me a presentation control, I can share my screen and kind of show Central for a little bit here.
There you go, Brian.
Excellent, thank you. And just to confirm, you can see my screen okay?
Yes.
Perfect. So here we're looking at my personal account, my lab account. This is Aruba Central, our cloud-based network management platform. It's something that we honestly recommend down to the smallest customer, 1 AP, 1 license, to the largest customer. As an example, Lowe's is a customer that's using Aruba Central today, 2,300 locations, 65,000 network devices. So just a reference to the range of scale that this platform is able to support. Now, I know we are short on time, so we're not going to do a full-blown demo clicking on all the capabilities and features of the platform, but I do want to highlight a couple of things that we talked about. So application kind of performance here, we have that feature set of AppRF, which does need to be turned on. In this platform, you can see the applications running across your network. You can also categorize those applications. You can see the uses of those applications, and we can view that from a global standpoint, a group standpoint, a site standpoint, and I can even look at an individual user, so down to that user level, to see what applications, or endpoint even, to see what applications are being used by that endpoint across the network. This is something that we do support, data retention on, so we can look back 3 hours all the way back to 3 months. And there's a couple different views of this. You can see a list view versus a summary view. We can generate reports off of this content as well, so a lot of really useful information here. I'll also show the client section. So going into clients, this is something that we refer to as our client details page. This is something that's incredibly relevant. So if I click into this wireless client, not only can we see information on the client device, we can also see information about the SSID that said client is connected to, the AP broadcasting the SSID, and even the switch that the AP is connected into on, and which port on the switch the AP is plugged into. There's a ton of really good content here. This is very, very useful from a troubleshooting standpoint. Green means good, right? Yellow is fair, red is poor. You can see all the kind of circles and text of color here has a green hue to it, but definitely helpful from a troubleshooting standpoint. The other thing that I'll quickly run through just to show you, I'm going to go into my Wi-Fi home group, and I'm going to go to configure a new SSID. And I just want to show you how we can do a little bit of the enforcement piece here. So let's give this a test name, and we'll just call it test 1, 2, 3, 4. Advanced settings. So in here, you can do things like bandwidth control. If this is going to be a guest network, you can throttle this down on a per network basis or even on a per user basis. But jumping ahead here, I'm going to go over to the access section. Lots of different options for authentication, from a captive portal to a passphrase to 802.1x, all that supported. But jumping over here to access, I want to highlight the ability for our APs to essentially enforce access rules. And this is where I was talking about, not only do you have the application visibility, but you also have control over this application. So if I specify application, I'll say Facebook, and I'm going to be real nice and say, sure, I'm going to allow you to use Facebook on my network, but I don't want you to steal all our bandwidth with that, so I'm going to throttle you down to 20 kilobits a second, right? You're not going to be streaming a whole lot of videos at that data rate. On the flip side, instead of throttling, obviously there's the option to deny, but let's look at something that's more business critical. So internally here, we use Microsoft Teams quite a bit. I'm not going to throttle that down. Instead, I'm going to prioritize that traffic, so I can assign an 802.1p priority tag, and I can assign a DSCP tag. And even if you're not familiar or comfortable with what those mean, essentially this is giving this type of traffic prioritization over any other type of traffic running across the network. So prioritizing the traffic of mission critical applications is something that we can easily do with our APs in our cloud platform. So on that note, I'll go ahead and stop share, and then I'll turn it over back to you, Alex and Chris, for addressing any final thoughts and any questions that may have come up.
All righty. There we go. You should be seeing the summary page. So to wrap things up here real quick and get into the question and answer session, keep in mind a good wireless network is going to start with a solid design based on your needs, both today and also for the future. You want to make sure you're picking the right access point vendor that has all of the options that you need. Sometimes you might need to consider 2 different vendors, but most of the time, most of the vendors have what you need. Make sure you have a good solid wired network. That's your firewalls, routers, switches, cabling to support the wireless network. Make sure you're doing your configuration properly. Don't rely on set it and forget it. Make sure you come back to care and feed your new pet, which is your Wi-Fi network. We don't want any starving pets out there. And also make sure you take a look at some of these great low-cost tools that are out there to get started with your monitoring, your vendor options, such as those from HP. And then, this will help take it to the next level. And so with that, I'm going to open it up to questions and answers. And Chris, take it away.
Thanks so much, Alex. Brian? So I had a couple questions here. So first one I think is for Brian. And it's just kind of, you touched on some of these things, but maybe the person was asking for more of a summary. So there's so many vendors out there. What one or two things really set Aruba apart?
Yeah, that's a fantastic question, and appreciate you asking that. So in terms of differentiation for us as a wireless vendor, it's something where we have a solution for any need that's out there, right? Whether it's indoor, whether it's outdoor, whether it's warehouse, we have a wireless product to fit that kind of scenario, as well as a platform to manage at scale and multi-site, right? So that's a part of it. The other part of it is going to be the functionality that we offer. I know AI is everyone's favorite buzzword. There's a lot of AI functionality built into our platform today, with more coming in the future. And additionally, from I would say almost RF roadmap standpoint, we have members of the company that sit on the board and work with institutions such as the Wi-Fi Alliance to ensure that our wireless products are Wi-Fi Alliance certified. That's not something that every vendor can claim. We have individuals from our company that are helping to shape standards such as Wi-Fi 7, which was recently released, as well as members that are communicating to help create the new standard of Wi-Fi 8. So certain things like that should really put a lot of confidence in a customer looking at HPE Aruba as a viable solution offering, looking at wireless not only today, but 3, 5, 10 years down the road.
Right. Thanks, Brian. And the second question I had was just before Alex is how do I know when I should just fix what I have versus considering a redesign and installing new?
That is a tough question, and one that we get asked quite often. A couple of things that come to mind. Number one, I would be looking at the age of your equipment. If you're starting to hit the 5-year or older mark for the equipment that you're thinking about replacing, that's probably a good time to consider it. Something else to consider, are there any features that you need, absolutely must-haves, that are not available today? Also, the ability to support your current environment. And so that comes in a couple of different ways. One is your gear coming to an end of life. Once it hits end of life, is it going to get any support updates? Are you going to be able to be protected? With today's hacking and everything going on, security is very important. And so if your equipment's end of life and it's not being supported, then you want to be able to get replacements as well. If something fails, are they even going to have replacements available? Or if it's a new thing, is it going to work in your new or your older environment? So basically, to wrap that kind of in a tighter package, I look at the age of the equipment. If we're heading over 5 years, if we're in an end of life status where we're not getting support or not getting security updates, and are you missing any features that are absolutely you need moving forward? That's it. That's pretty much it. That's kind of where I go for my decision between keep it and fix it, or dump it and move on to the next.
All right, thanks, Alex. So those are the questions. Just want to point out that there will be the evaluation that's coming around. We do pull one of those out of the completed ones for a $50 Amazon gift card to try to say thank you for your time and to make it a little bit more fun. Amazon always seems to be the gift that fits. A few things that I'll just point out that are on the evaluation for additional resources that might be helpful as you are looking at your network. One is there's a no charges kind of a Wi-Fi planning workshop that would be with Alex. The same thing for looking at one that would be for kind of a Wi-Fi troubleshooting and tuning. You may want to look at an engagement for that. We could talk to you about that. Our Wi-Fi site survey or design, and of course, additional information about HPE Aruba switches and wireless solutions as well. With that, I want to say thanks to everybody for your time. Hope you enjoyed the pizza and the information today. Thanks so much to Alex and Brian, and hope you have a great afternoon. Thanks, everybody.